Could you introduce yourself and just say where you're coming from and what's your field of study?
Yes. So my name is Jesús De Loera. I'm a professor of mathematics at the University of California, Davis. And my area of research is, I will describe it as discrete mathematics, a very computational type of discrete mathematics. I'm interested in algorithms, but also software implementation, and I like geometric problems that have a very geometric nature, discrete, but at the same time, very geometric.
And what brings you here?
Well, I'm very interested on, let's say, the frontiers of what AI can do and cannot do, and also, in some sense, to understand the models better.
And what is your submission about the problem you wrote?
So the submission of the problem I wrote is a problem that actually has a completely algebraic formulation. And I could tell you the formulation if you want, but without going into the technicalities, essentially it's a very concrete number to compute that is known to algebraic geometers, that is known to combinatorialists, that is known in many areas of mathematics. It's a famous number called the Littlewood-Richardson coefficients. And to actually get these numbers, to compute a specific number, is extremely hard. And you require a lot of intuition and knowledge of different areas of mathematics to actually know, to get to this number. It's not sufficient to you cannot guess that number for sure. You cannot, because these numbers are typically rather arbitrary, right? There's no pattern to them or anything like that, very easy, at least not easy to identify. And again, nevertheless, they are quite interesting in many areas of mathematics. So this would be something that a human mathematician might be interested to know at some point.
I see. How long would you expect an army of grad students to take to solve your problem?
Right. So I actually can be confident that a graduate student that works with me probably will take a year of his or her time to figure out an answer. And I think with enough help and, putting a lot of effort, they will probably do it.
And is that why you expect it to be hard for AI, or is there anything else
That's one reason I expect to be hard. And also because it's, if I give this to, let's say, a first-year graduate student, they will try the obvious things that they come in books. But because it's such a hard problem, the obvious things will not work. And I have tried them to be sure of that. So I'm pretty sure that if AI, let's say, tries what is on the web, it will try something, but it will get stuck, right?
I see.
I'm hoping that my problem is hard enough to last for sure 5 years, let's say. Let me put it that way.
And given that, would you expect a professor armed with an AI agent to do it quicker? Or would the AI help?
Certainly. That would be the case. I think, I think that's a very important question. I think I don't personally foresee AIs replacing us, but rather augmenting us. I'm old enough, to tell you that I lived in the time there were no pocket calculators, and it was a game changer, right? You suddenly have a pocket calculator, you can do more, but you are kind of driving the whole thing. I mean, you're asking the questions, you're driving and I think this is something similar at a higher scale, rather higher, several orders of magnitude more than a pocket calculator. But it's still, it's an amplification that we are going to be able to have as research mathematicians.
Do you think proposing the questions or coming up with conjectures is the harder part?
I do, actually. To some extent, I think one of the big important things in mathematics is the creativity of asking the right question. Because asking the right question, first of all, means that attracts other mathematicians to work on it. And asking the right question also means it's to some extent central to the whole enterprise of mathematics. I am still to see AIs being able to ask these kinds of questions, right? To me, that's one of the frontiers. I'm interested in this question in particular in my own research.
Do you think AIs could also get better at the question asking thing?
I certainly am interested in developing techniques to do that, just like we have seen in the picture level. AI DALI produced these amazing new pictures that seem very innovative, from combining several artists, using new colors, things like that. Art that seems to be very creative. I can imagine that could be also used for mathematical statements, and that could happen perhaps someday for mathematical statements. But there needs to be some kind of theory about it, and that's what I'm interested about.
If we're in this world where humans are asking all the questions and AIs are helping us really well to solve them, how much value is there in a theorem that is proven, but the proof is just AI generated and incomprehensible to anyone? And also it's verified, but we just can't understand it.
I have discussed the following variation of your question with many people. The four-color theorem has only a proof that requires computers as of today, right? And I have discussed also the proof of the Fermat's last theorem. And I much rather prefer the computer proof of the four-color theorem over the Fermat's last theorem. And I'll tell you why. I find the proof of the four-color theorem more democratic. I can take 10 smart undergraduates from any state university in this country, put them in a room and tell them, look, this is the algorithm to prove the four-color theorem. And within a few months, they will have reproduced the computer programs that actually do this proof and verify that the theorem is correct. On the other hand, you have Fermat's last theorem, which is, it's a human proof. 15 people in the world probably understand it completely. I'm certainly not one of them. I don't even think that I can say, hey, take my graduate students and train them on this, and they will, in let's say, less than 7 years, probably figure out how to read the whole thing. So which one is more valuable? I find actually the computer proof that can be reproduced more valuable, even if because in some sense it's reproduced by more people, can actually be verified by more people. So going to that, the case that you presented is kind of a third situation, right? Because it's produced by a computer, but it cannot be in some sense verified, easily understood, neither by the full experts, neither by a bunch of undergraduates. So how do we deal with that paradigm now? I tend to say, well, if enough experiments verify this, maybe you can trust it to some level. Maybe we should start thinking about probability or likelihood of truth rather than full certainty. This is something that other people have discussed before. We have theorems that are absolutely true, like 2 + 2 = 4, or the irrationality of square root of 2, things that people have gone over and over again, these proofs, and are sure. Versus things that, well, we think is pretty likely correct and have been verified even by lean or by some formal system. And then there are this other gray area that, papers that are published in good journals that a handful of experts have verified them. But that's about it, right? So they make mistakes. Everybody makes mistakes. Even ChatGPT makes mistakes. And so you have to think about how many times has this been verified, by who has this been verified, the rigor of the verification, et cetera, et cetera.
Do you have much hope for AI and math, or are you more hopeful or more fearful?
I'm very, very afraid. I'm afraid of the humans hyping or exaggerating the power of AI, number one. It's just a glorified pocket calculator. This is how I feel right now. As of today, I just feel that, yes, it's a great tool. It's going to help speed up research for many mathematicians that use it. But it's not lack of error. Right? There's plenty of problems with hallucinations. We've heard about this. I mean, I can tell you a lot of things that has happened in my research where the hallucinations are terrible. And I also feel that the creativity is not there yet to actually be on its own, like start doing research and generating new things. And I don't know when that will happen. I'm not fearful of the technology on its own as the technology. I'm really fearful of the way that people will interpret it or use it. It also has the possibility of corrupting mathematics. For example, stating things that are false and people believing this. In fact, I can tell you an instance where ChatGPT and I think other LLMs have said things such as, "Oh, the following result is known, and here's a paper." And if you actually are careful and check, the paper does not exist. You see, so it's complete bullshit. And I have also my students relying on ChatGPT and trusting it. And I told them, don't trust it. You use it, but don't trust it. If you use it as some kind of conversational partner, then it's okay. But if you use it as you're better than me, I accept everything you say blindly, then that's what we're in trouble. And that's how I feel most people are using AI, even mathematicians. I mean, I tell my students, if you get stuck and you cannot do the answer, you can ask ChatGPT, just check, go over the logic and try another problem. And so it can actually help you learn. It's like having a tutor, right? But if you trust it blindly, that's where it goes wrong.
Do you think math will become more empirical, experimental as AI systems get better because it will be data collection?
I'm definitely expecting that that's something that will change. In my generations, writing mathematical software, I'm all from the generation where people will tell you, you're not going to get tenure because you write too much software, or if you do too much experiments, or your proofs were done by computer. For example, one of my first papers, I found a counterexample that people had never expected was going to exist. And then he found by computers, like a little bit, people were like, why not just create the counterexample with your mind? Well, yes, I did create with my mind by programming and finding clever algorithms to do it, right? It's a different way to do things. So, but I think this hopefully will change in that the appreciation for computational methodology and experimentation in math will become more reputable, let's say, within mathematics community. I expect that to happen, hopefully. Yeah.
And just broadly, to what degree do you expect AI to reshape math?
Well, so in the optimist scenario, it will reshape math by allowing us to learn more things. Students will have a tutor, for example. That's in a beautiful world. This will help students learn more material and practice more problems because the AI can provide more interesting problems for practicing, for exams. So, and then when we train mathematicians, the AI can help them summarize the literature and move faster with the research. And for research mathematicians working, it will help them as a great tool. So this is the positive view of the future, right? The negative view of the future is people being dissuaded from studying mathematics because, what's the point? AI can do better than me. And that is the future I don't want to see. I mean, I hope that so that's one of the reasons I came to this meeting, to really be sure that we understand what is the reality of this tool.
I want to ask you a few rapid fire questions. So how long will AIs take to solve your problem?
10 years.
10 years.
Yes.
Oh, that went up. Okay. How much will AIs change math research on a scale from 0 to 10, where 0 is the level of a pocket calculator and 10 is human mathematicians are no longer needed?
I certainly think it will be probably a 5.
Oh, okay. And then how much will AI change the world, where, again, 0 is level of a pocket calculator and 10 is like more than the Industrial Revolution?
I think that's probably going to be a 7 or an 8. And simply because people, again, outside mathematics are more trustful of things that they may not understand, right? That's a little bit my concern here.
Thank you. And then would you rather do all the math yourself or give part of it to an extremely capable AI assistant?
I don't mind having an AI assistant.
Another similar question, your general outlook on AI progress from 0, which is you would stop it entirely if you could, and just remove all AIs, and 10, accelerate as much as possible, make them as smart as possible.
I will actually say that maybe I'm a 7 or 6, because I think we cannot just blindly develop things. For example, testing, like is happening in this meeting, is important. Like the understanding has to be there, right? And certainly, I think for example, when the atomic bomb was developed, there was some level of understanding of the process, right? So you cannot not do that. I mean, you have to go to some understanding level and understand the limitations, the powerful, at least estimate it. And I don't want to see development that is just develop, and not have some kind of self-reflection and analysis.